I am going to present how to troubleshoot Evidian SafeKit by analyzing logs and their messages, so you can resolve issues on your own. This process will help you identify the root causes of common issues and provide step-by-step solutions. Here is an outline of the different topics covered for Evidian SafeKit troubleshooting. In 1, we encourage you to analyze the logs yourself to identify and resolve potential issues. In 2, we explain how to run an application without SafeKit. In 3, we describe how to take module snapshots at a customer site and how to diagnose and resolve issues quickly from snapshots. In 4, we cover issues that can happen with the web console. In 5, we do the same with command lines. In 6, we address how to solve mirror module issues. In 7, we focus on solving farm module issues. In 8, we explain how to solve checkers issues. Let's start with analyzing the logs on your own. You can make the log analysis either with the monitoring feature of the console or with command lines. In the console, first select the module and the node on the left side. Then the log of the module on the node is displayed on the right side. The log is displayed in real time with 3 buttons: Resume, Suspend, and Download. By downloading the log to your workstation, you can use your favorite editor to analyze the messages. As shown in the second text box, the console provides an option to select messages according to their types. Here are the different message types you can select, represented by the 4 icons in the console. The first icon represents critical messages associated with error detection. The second icon represents event messages related to changes in local or remote states. The third icon represents user messages when the user performs an action on the module. The fourth icon represents script messages when module scripts are executed. These 4 types of messages are saved in a log named the non-verbose log. As shown in the third text box, you can also filter messages based on content or a date range. Finally, you will find in the root directory of SafeKit 2 command lines to help with debugging: SafeKit log view and SafeKit log save. The -A option allows to have the verbose log. Let's explore the module states timeline feature. To access this feature, click on the clock icon located in the Windows header. The timeline will appear as shown in the figure on the left. This timeline displays the module states on all nodes in reverse chronological order, starting with the most recent date. This visual representation helps administrators quickly understand the current status and historical changes of the module. The timeline shown is the one available at the time of loading. To refresh the timeline with the latest date changes, simply click on the refresh icon. Additionally, you can click on an event in the timeline. As shown in the figure on the right, the module log associated with the event will be displayed. It's important to note that the clocks of the 2 nodes must be synchronized for the state changes to be accurately mapped. This ensures that the timeline provides meaningful and precise information about the module states. Let's consider now some main module log messages. For a full list of messages, please refer to the Log Messages index in the user's guide. In the module log, you will encounter various types of messages emitted upon error detection by checkers, along with the actions triggered to solve the error. For instance, the process monitoring message issued by AirD indicates that the process MySQLD.exe was not running. Consequently, an action restart was initiated by AirD to restart the application. Secondly, the IP message shows that the virtual IP checker has set its resource to down, meaning that either there was a duplicate virtual IP on the network or the virtual IP has been removed. The action stop-start has been triggered from the failover rule IP_failure to reconfigure the virtual IP. Thirdly, the resource custom.http has been set to down by a custom checker, and an action restart has been initiated from the failover rule c_http to restart the application. Fourthly, the TCP checker has set its resource to down because it has detected an impossibility to make a TCP connection to the application. The action restart has been triggered from the failover rule t_web_80 to restart the application. Note that the failover rule names of TCP, ping, and custom checkers are prefixed by t_, p_, and c_. Let's consider other main module log messages coming from checkers. Firstly, The network interface checker message indicates that the interface was detected down. The action wait has been triggered from the failover rule interface_failure, waiting for the repair of the network interface. Secondly, the ping message shows that the ping checker has set its resource to down because its ping to an external component was not answering. An action wait has been triggered from the failover rule p_outer, waiting for the external component to answer again to ping. Thirdly, the resource custom.sql has been set to down by a custom checker, and an action stop start has been initiated from the failover rule c_SQL to restart the application on the other node if it was running the module. Fourthly, the module checker message means that the external SQL Server module was down and the action wait was initiated from the failover rule module_failure, waiting for the restart of the external SQL Server module. Fifthly, the split brain message shows that all heartbeats have been lost and the split brain checker was not able to reach the witnesses. Thus, the action wait has been triggered from the failover rule split brain_failure to wait for the recovery of heartbeats. Let's consider now the best practices to analyze the module logs. Start by identifying the root cause of a problem. For that, firstly, read the non-verbose log. Secondly, go to the date when the problem occurred. Thirdly, go up in the log to identify the cause of the problem. When there is a loop of errors, firstly, go up in the log to find a stable state, like local state alone ready, local state prim ready, or local state second ready for a mirror module, or local state up ready for a farm module. Secondly, go down in the log to find the initial error. When the problem is global, firstly download and open the log of node 1 and node 2 in two different windows, facing each other. Secondly, match node 1 and node 2 messages by date to understand how the cluster has globally evolved. Be careful if the clocks on nodes were not synchronized. After examining the module log, let's now look at the script log, which contains the output messages of the restart scripts. You can analyze the script log either with the console or on the node side. As shown in the figure, you can click on a restart script message, such as start prim, to open the script log for this script on the right side. You will find the outputs of service startups and stops in the script logs, along with any potential error messages that can help with debugging. On the node side, the script logs are located in the var directory of SafeKit under the directory of the module. Each restart script execution is logged in an individual file with its date and time of execution. Let's talk about the best practices to analyze the script log. Let's explain the problem analysis in the slide. Among the messages in the script log, like the messages of point 1 and point 2 on the right of the slide, you should search for error messages, typically the message 2, which indicate that the service failed to start. Scripts can log messages or execute commands in the module log, as shown in points 3 and 4 on the right side of the slide. Look for error messages logged by the script, such as message 3 indicating that the start prim script has failed. Also, search for actions initiated by the script, like message 4, which indicates that a stop action was initiated by the start prim script. Finally, it is necessary to understand application errors when the application has not been started or stopped correctly. On Windows, you can find these errors in the event log. On Linux, check the system log messages. Additionally, specific application logs, which are not included in the SafeKit snapshot, can also provide valuable information. Let's now explain how to run an application integrated inside SafeKit, but without the SafeKit runtime. Let's first discuss the need for this use case. You want no SafeKit processes running, only your application. You want to start or stop your application using the start prim and stop prim scripts in a mirror module or the start both or stop both scripts in a farm module. You want to set the virtual IP address as an alias on the local network interface if a VIP tag is defined in userconfig.xml. Lastly, you want to pass environment variables defined in the user tag of userconfig.xml to the start and stop scripts. Now let's examine the procedure for a module named AM. Firstly, stop AM on all nodes. Secondly, log in as an administrator on Windows or root on Linux. Thirdly, open a PowerShell on Windows or a shell console on Linux. To start the application, go to the private/modules directory and run the start wrapper script of the module. To stop the application, run the stop wrapper script of the module. Please note that wrappers are generated at each configuration of the module. Let's see how to take module snapshots for supporting a customer. For supporting a customer, you have to take a module snapshot on each node, either with the web console or with the SafeKit command. As shown in the figure on point 1, you can download both mirror module snapshots from Node 1 and Node 2 by clicking on the global menu of the mirror module and opening the debug submenu. This will download on your workstation two .zip files corresponding to the two module snapshots of the two nodes. To do the same with the SafeKit command, you will have to execute the following procedure twice on Node 1 and on Node 2. Firstly, log in as an administrator on Windows or root on Linux. Secondly, open a PowerShell on Windows or a shell on Linux. Thirdly, go to the root directory of SafeKit. Fourthly, run the SafeKit snapshot command, providing the module name and the absolute path of the .zip file. This file will be created and will contain the module snapshot of the node. Fifthly, repeat the same procedure on the other node. There is also a dump command useful to dump in real-time all SafeKit logs, which is helpful to capture a state in real time when typically a replication problem occurs. The dump will be included in the snapshot operation. Let's now examine what a snapshot is and where you can find interesting information to analyze a problem. A snapshot is a zip file that contains the last 3 configurations of a module and the last 3 dumps of a module on a node. Inside the zip file, you will find directories associated with these configurations and these dumps. Let's examine the module configuration in a snapshot. As illustrated in the right figure, begin by opening the directory containing the latest configuration. Within this directory, you'll find the conf subdirectory, which houses the userconfig.xml file of the module. Additionally, you'll find the bin subdirectory, which contains the start prim and stop prim scripts for a mirror module, or the start both and stop both scripts for a farm module. By examining these files, you can gain insights into how the application has been configured within the module and troubleshoot the application integration. If needed, you can compare these files with previous configurations to identify any changes or discrepancies. Let's now consider how to analyze a problem in a module dump. As shown in the figure on the right, first open the dump with the date closest to the problem. In this dump, open the module log.txt file to review checker actions and module state transitions. Then, check the script logs in the user log subdirectory for application start or stop issues. Also, use the Windows or Linux event logs to understand issues on application errors. If you have any network communication issues between nodes, examine the cluster.xml file to see how the networks are configured. Check also the detailed network configuration of the node in the heartplug.txt file, which contains network interfaces with their physical IP address, netmask, and virtual IP address if configured on the node. You will also find in the heartplug.txt file the OS and SafeKit versions, the license, the list of installed modules, the list of services installed on the node, and much more. Finally, the commandlog.txt file provides the list of SafeKit commands passed on the node. To facilitate searching and sorting through messages, the dump also provides CSV files that can be imported into Excel. For instance, with the logverbose.csv file, once it's in an Excel table, you can easily apply filters to view only specific types of messages. This makes it much simpler to focus on the information you need. This is a way to present a detailed report to the client about an issue that occurred in the cluster, leveraging the full power of Excel. Additionally, you can combine the logverbose.csv files from both nodes into a single Excel file and sort by date. This allows you to see how the cluster has evolved overall, providing a comprehensive view of the global cluster's behavior over time. The procedure on the left explains how to import a CSV file into an Excel file. Just be careful with the date formatting to ensure millisecond precision. The primary file to consider for importing into Excel is the verbose log of the module. However, you also have the files for module resources status and their history, as well as the SafeKit cluster state and the commands log of the node. As shown in the figure on the right, there are 3 additional subdirectories in the module dump. The licenses subdirectory contains the SafeKit license key files. This can be useful for resolving issues such as when the hostnames set inside the license key file do not match the hostnames of the nodes. The var subdirectory is a copy of the var directory of the node, including various runtime data. Lastly, the web directory contains the Apache configuration for the SafeKit web service, detailing how the web service is set up and managed. This can be useful for resolving issues with the SafeKit web service. Let's now examine the issues that may arise with the web console. You may encounter web console load or connection errors. First, check the browser. Verify the proxy and security settings in the browser. Ensure that the web console and the SafeKit nodes are running the same release number. Clear the browser's cache by pressing Ctrl and Shift while tapping the delete key. Secondly, check the SafeKit nodes. Check the firewall and SafeKit web service setup. Verify the SafeKit cluster configuration. Ensure that the SafeAdmin and Safe Web Server services are running. For HTTPS, refer to the connection issues with the HTTPS web console section in the SafeKit user's guide. To troubleshoot authentication issues with the web console, ensure that the same password for the admin user is used on all nodes. To reset the password on each node, log in as administrator on Windows or as root on Linux. Open a console such as PowerShell or Shell and run the web server CFG command with your password. By setting the same password on both nodes, this should resolve any authentication failures of the admin user or connection errors on the other node. Let's now examine the issues that may arise with the command lines. If you encounter an unsuccessful global command with safekit-h, it may be due to an authentication issue. In this case, test the global command by logging in as administrator on Windows or root on Linux and opening a console such as a PowerShell or a shell. Test the global command with safekit-h star level. If there is a curl error with the unauthorized message, it means that there is an authentication issue between nodes. This problem may be due to the fact that the password is not the same on all the nodes. To reset it, on each node, log in as administrator on Windows or root on Linux. Open a console such as a PowerShell or a shell and run the web server CFG command to reset the admin password on both nodes. Alternatively, you can run web server CFG to reset the password only of the global command. Let's now examine the issues that may arise with a mirror module. An issue arises in a mirror module when no nodes are up to date. In this case, as shown at the bottom of the slide, the console shows two nodes in the stop red state with the not up-to-date message. If you try to start both nodes with the start command, they will both go into the wait red state because they will detect that they are not up to date and cannot start without resynchronizing their local data. This situation arises at the first installation or after a double simultaneous power outage. In this case, the resource rfs.uptodate is down on both nodes, and you can check this value using the safekit state-v command. To solve this problem, select the node that you consider to be up to date, let's say node 1 in our example, and start it as the primary node using the safekit prim command. Node 1 will then transition to the alone green state. Next, start the other node, node 2 in our example. Use the safekit second full sync command if you want a full synchronization of its data. After the synchronization, the cluster will return to the prim second green state. Let's consider a node that is in the prim green state or alone green state, which typically means the application is running. However, the application is not started, not operational, or inaccessible by clients. To address this issue, first verify the start prim and stop prim scripts and search for errors in the script log of the module located in the SafeKit var directory. Then, check for errors in the application and event system logs of Windows or Linux. Additionally, search for errors in the error logs specific to the application. You can try a local restart of the application using the safekit restart command. If the node is in the prim state, attempt a failover to start the application on the other node using the safekit stop command on the prim node. Ensure that the application's clients are configured to connect to the virtual IP. If all else fails, reboot the node. Let's now consider a file resynchronization issue with Node 2. Node 2 attempts resynchronization of its files 3 times, the max loop value, before stopping. Each time, the resynchronization fails, and ultimately, the data are not resynchronized on Node 2. As a result, the files remain inconsistent on Node 2 due to partial resynchronization. When faced with this problem, the first step is to search for errors in the module log on both nodes. Start with the module log of the secondary node. Use the safekit logview command with the -a option to get the verbose log and retrieve all messages from the resynchronization process. If you encounter a file access error in the module log of the secondary node, ensure that no remaining process of the application locks the files, preventing the resynchronization process from succeeding. Additionally, verify that the stop prim script stops all services of the application and that these services are set to start manually at boot. Also, exclude replicated directories from antivirus scanning to prevent interference between the antivirus checking files and the resynchronization process. In the case of a timeout on request processing, verify that both the network and the disk are functioning properly. It's also advisable to start the secondary during an off-peak period to avoid any potential issues. Let's now consider the issue with the alone degraded state on Node 1. Before the degradation, the state was prim second, indicating a functional replication. Then, due to an issue in the replication mechanisms of Node 1, the prim node transitions to the alone green degraded state, while the other node transitions to the wait red state, waiting to resynchronize data from the alone node. The application is still running on the alone degraded node, but the replication mechanisms are non-functional, and it is not possible to resynchronize data from the alone degraded node. You can check the degraded status with a resource named rfs.degraded and displayed with the safekit state command with the -v option. To solve this problem and restore the replication mechanisms on the alone degraded node, stop Node 1 with the safekit stop command, and then start it as primary with the safekit prim command. Then, Node 2 in the wait red state will be able to resynchronize its data. Let's now consider a strange and incoherent state of the cluster, where Node 1 is in the alone green state, ready to accept a resynchronization from Node 2. However, Node 2 is in the wait red state, waiting for Node 1 to accept its resynchronization. In this case, there is a communication issue between Node 1 and Node 2. Note that the states of each node can be displayed using the safekit state command. To solve this issue, verify the following on each node. Confirm that the SafeAdmin service is running properly. Ensure that the SafeKit cluster has the same signature on both nodes by using the SafeKit cluster confinfo command. Confirm that the module has the same signature and ID by using the SafeKit cluster state command with the -h* option. Check the firewall setup to ensure there are no blocking rules. Finally, verify the network connection and DNS resolver to ensure they are functioning correctly. Let's now examine the issues that may arise with a farm module. The first thing you want to know with a farm module is whether the load balancing on the virtual IP address is functioning correctly. SafeKit provides a way to verify this with a mosaic through its web service. First, set a load balancing rule on TCP port 9010, which is the port of the SafeKit web service, and configure the filter with the on_port value. This configuration allows the TCP sessions of the same client to be load balanced across all nodes of the farm. Secondly, from an external workstation, be careful, not a local node of the cluster. Connect a browser to the virtual IP using HTTP, port 9010, and the mosaic.html URL. In the form that follows, enter the name of the module to be tested. If the farm module is running on both nodes, meaning Node 1 is in the up green state displaying 50% and Node 2 is also in the up green state displaying 50%, you will see a colored mosaic. Each square in the mosaic represents a TCP connection response from either Node 1 or Node 2. However, if the load balancing is not working, you will only see responses from one node. To solve an issue with virtual IP load balancing, follow these steps. Firstly, ensure that you are on an external workstation and not on the nodes themselves. On a node, a browser will display only local TCP connections to that node. Secondly, verify that the network interface, on which the virtual IP is configured as an alias IP on both nodes, is in the same subnet for both nodes. This is a prerequisite for proper load balancing. To check the network configuration, use ipconfig/all on Windows and ipaddr show on Linux. Thirdly, on each node, check if the node is managing connections on the virtual IP. To do this, use the netstat command with a filter on the virtual IP and check if there are any established connections or connections in the time-wait state. This will help you determine if the node is actively handling network traffic on the virtual IP. Fourthly, stop and start the module on each node to determine which one is taking connections and which one is not. Let's now consider a strange and incoherent state of the cluster, where Node 1 is in the up green state managing 100% of the traffic and Node 2 is in the up green state managing also 100% of the traffic. In this case, there is a communication issue between Node 1 and Node 2. To solve this issue, verify the following on each node. Confirm that the SafeAdmin service is running properly. Ensure that the SafeKit cluster has the same signature on both nodes by using the SafeKit cluster confinfo command. Confirm that the module has the same signature and ID by using the SafeKit cluster state command with the -h* option. Check the firewall setup to ensure there are no blocking rules. Finally, verify the network connection and DNS resolver to ensure they are functioning correctly. Let's consider a node that is in the up green state, which typically means the application is running. However, the application is not started, not operational, or inaccessible by clients. To address this issue, first verify the start both and stop both scripts and search for errors in the script log of the module located in the SafeKit var directory. Then, check for errors in the application and event system logs of Windows or Linux. Additionally, search for errors in the error logs specific to the application. You can try a local restart of the application using the SafeKit restart command. Ensure that the application's clients are configured to connect to the virtual IP. Let's now examine the issues that may arise with checkers. For maintenance operations that require stopping the application monitored by SafeKit, it may be necessary to disable process monitoring to avoid an automatic restart triggered by AirD. This might also be the case if AirD triggers automatic restarts that are not desired by the user. Firstly, let's examine how to deactivate AirD without reconfiguring the module. To suspend or resume process and service monitoring, you can either use the console or the commands SafeKit AirD off and SafeKit AirD on. To check if AirD monitoring is on or off, you can consult the status of the resource named usersetting.ard. Secondly, let's examine how to deactivate AirD with reconfiguration of the module. For this, you can edit userconfig.xml either with the console or directly on the node. You can set action equals no action in the AirD section of userconfig.xml to deactivate the monitoring of a process or a service. This way, you will only receive a message in the module log, but no action will be triggered. Alternatively, you can comment out the AirD section. Note that there should be no comments included within these comments. Then, you need to stop the module, distribute the userconfig.xml on all nodes, reconfigure the module on all nodes, and then restart the module. All these operations are simpler to perform using the console. In the same way, for maintenance operations that require stopping the application monitored by SafeKit, it may be necessary to disable checkers to avoid an automatic restart triggered by them. This might also be the case if the checkers trigger automatic restarts that are not desired by the user. Firstly, let's examine how to deactivate checkers without reconfiguring the module. To suspend or resume checkers, you can either use the console or the commands SafeKit checker off and SafeKit checker on. To check if the checker monitoring is on or off, you can consult the status of the resource named usersetting.checker. Secondly, let's examine how to deactivate checkers with reconfiguration of the module. For this, you can edit userconfig.xml either with the console or directly on the node. You can comment out the checker section and the failover section if it exists. Note that there should be no comments included within these comments. Then, you need to stop the module, distribute the userconfig.xml on all nodes, reconfigure the module on all nodes, and then restart the module. All these operations are simpler to perform using the console. A common behavior of SafeKit that is often misunderstood is a restart or stop-start loop of a module on a node followed by a stop. This loop corresponds to an error detection on a node, an attempt to trigger a restart or stop-start action that does not resolve the error, reproducing the same error detection in a new restart or stop-start attempt, and so on. The loop is bounded by the maxLoop variable in userconfig.xml, which causes the module to stop on the node. In this case, you will see the message action stop called by maxLoop in the module log. To solve this issue, verify the following. First, identify the checker causing the actions in the module log. Next, check that the checker is working properly, especially if it is a custom checker. Verify that the functionality under test is operational when the checker is active. If needed, delay the activation of the checker by using the start_after parameter for AirD or adding a sleep command at the start of a custom checker. It could indeed be a case of the checker starting too quickly while the application is not yet fully launched. Additionally, increase the error detection timeout to allow more time for the application to respond to the repetitive tests of the checker. Finally, if necessary, remove or comment out the checker configuration from the userconfig.xml file. Thank you for your attention. If you have any questions or need further clarification, please feel free to ask.